You've loaded the receipt. You've checked that it contains data and a signature. Next, you have to actually check the receipt's signature against Apple's signature. But how do you know the signature is actually an Apple signature? You do this using Apple's root certificate. You use this certificate to verify that the receipt was produced by Apple. If the signing doesn't match, then you know not to trust the receipt. If the signing does match, then you know the receipt is at least initially trustworthy. The first thing you need to do is get the Apple root certificate. Apple makes this really easy to obtain. Open the following URL. Next, download the certificate and add it to your project. Now comes the point where you validate the receipt against the signature. Open up applereceipt.swift. In init, add the following. Here you call a validate signing method, passing in the payload. The payload, if you remember from the last episode, is the receipt container that has both the signature and the data. Now for the validate signing method. This will take in an unsafe mutable pointer and return a Boolean value whether the signing is valid or not. Now you're going to load Apple's root certificate. First, get a URL to the certificate and convert it to data. If you can't get the root certificate, then set the error as an invalid root certificate error. Now you need to convert the data into a uint8 array so you can pass it into OpenSSL. First, create a new bio object. Next, initialize the array from the certificate. Now write the certificate data in the root cert bio variable. Finally, you need to convert the data to an X509 format and then clear out the memory. Okay, you have a cert all ready to go. Next, you need to create an X509 certificate store. This is a container used for verification. Now you add your cert to the store using the store add cert function. Next, you initialize OpenSSL for validation. The open-init add all digests loads all the hashing functions. Now you do the actual verification, passing in the receipt in the store. And that's it. You verified the receipt. Remember, this is all done to make sure that the receipt is from Apple. You could skip writing all this code, but that means your app would accept any receipt and thus accept any data passed into it. Meaning, I could send your app a receipt that unlocks all your features with $0 down. Once you've checked the receipt signature, examine the result of that check. You check to see if the result is 1. Otherwise, it's not a valid receipt. Now, some of you may be thinking, you just use a magic number. Why not create a constant instead so the code is easier to read? It may make the code easier to read, but it also makes the code easier to hack. A determined person could change the value of the variable in memory, turning an invalid receipt into a valid one. That's why you code against magic numbers when writing validation code. Welcome to Opposite World. One last thing, you created a new store, so now that you're done with it, you must free the memory. And with that, you have your receipt validated. Now comes the fun part, actually reading the data in the receipt. But to do this, you need to write some helper methods for decrypting ASN1.